I love monitors. I love working on monitors. I think monitors are really fantastic to work on. I mean, I've worked on lots of stuff, and I know how to do lots of technical kind of stuff. But of all the things that I repair, I really like monitors the most, really. And I like monitors for a couple of reasons. Number one, it's just absolutely fascinating how a monitor works. The way a monitor actually works is really, really interesting. And, of course, that's what we're going to go over this morning. But the other reason I really like working on monitors is that I can really produce on monitors. That is to say, it would not be unusual for me to be able to fix 6 or 8 monitors in a day. It typically takes about 40 minutes, maybe even an hour, to fix a monitor. Now, that's not to say there aren't challenging monitors. There are. And I kind of like those. I mean, those are pretty cool. But most of them are pretty straightforward, and you see the same kind of maybe half a dozen, 8 problems, maybe even a dozen problems over and over and over and over again in monitors. One of the things that I do in addition to techfest is I do a 2-week class, a 2-week, for want of a better term, a casino school class. And during that class, the main goal of the class really is monitor repair. That's really where I think most casinos should be. All casinos really can be totally self-sufficient in monitor repair. And in that class, I invite the students to bring in bad monitors. We just did one at Chip Inn's Island Resort in Harris, Michigan, which is in the upper PI of Michigan. And we had 15 people in the class, and everybody brought a bunch of monitors, and we must, in the 2 days of our hands-on lab, we must have fixed 25 or 30 monitors easy during that time period. And I didn't fix them. The students fixed them left and right because it's really, really straightforward, real easy to do monitor repair. So the other reason I like monitor repair is that it's real easy for me to get a bunch of monitors working in a short period of time. You know, there are challenging monitors as well, but by and large, they're pretty straightforward. Now, the monitors that we use in slot machines are technically known as raster scan monitors. It's called a raster scan monitor for reasons that I'll explain later on as we go through the class. Your home TV is also a raster scan monitor. Your computer monitor at home is a raster scan monitor. Virtually every monitor that you will work on in your normal life as a technician is a raster scan monitor. There is another type of monitor that exists. It's known as a vector scan monitor. Typically, those are used in military applications, air traffic control displays and stuff like that. But everything we use is what we call a raster scan. And again, I'll explain why that is later on. But a slot monitor like this one is really basically the same as your home TV. The only real difference is that there is no tuner in a slot monitor. That is to say, you can't hook up a cable or an antenna and get programming. What that means, though, is that in a slot monitor, you don't have all the complex circuitry needed to do that. The circuitry that's required to hook up an antenna is what's known as radio frequency or RF circuitry. And boy, that stuff's really hard to work on. The parts are real itty-bitty, and even the parts placement is critical. You can have a coil mounted like this, and it works perfectly okay, but if it's bent over like that, it doesn't work properly. It requires specialized equipment, a lot of specialized knowledge, and in fact, RF stuff is so hard to work on that typically, if you were to have a tuner problem on a regular home television, even a TV repairman wouldn't repair that. It's a module. He'd pop out the module and stick in a new tuner module. He wouldn't actually work on the RF stuff. But we don't have any of that in this. Also, in a home TV, there's some fairly complex color decoding circuitry. It's called chroma demodulation. Ooh, ooh. And chroma means color. Anyway, that's also fairly complex circuitry. In a regular standard television signal, which is known as NTSC, and we'll be talking about NTSC later on. It happens to stand for National Television Standards Committee, NTSC. It's the standard for video that we use in the United States. In a standard NTSC signal, the black and white signal is actually broadcast at a different time than the color. It's kind of like a coloring book where it has a black and white outline and you fill it in with color. There's a black and white signal, they call it luminance, and then later on there's a chrominance or chroma color thing, and there's a complex circuit in there that kind of combines the two and lays one on top of another. We also don't have that in a slot monitor. What's left in a slot machine monitor is all of the easiest things in a television to fix. That's what we're left with in a monitor, which is a good thing. The flip side of that is, unfortunately, that it happens to be all the stuff that fails the most. Those circuits that I mentioned, the tuner and the chroma circuits that are in a regular television, they don't fail very often. The stuff that's left in a slot monitor is typically all the stuff that works the hardest, and it's the stuff that fails the most. We'll be going over this again and again as we go through this in the next 3 days. It's something you should know as a technician. The things that work the hardest are the things that fail the mostest, really, in general. So as you'll see, and just relax, I'm going to go over this a bunch of times. Just relax, relax, relax. But as you go through this, you'll see that the things that fail are things like outputs, things that drive the outside world, things called output transistors or integrated circuits that are output devices. Those are the things that fail the most. There's lots of stuff in the monitor that you'll never see fail. And you just don't even have to worry about it. There's lots of stuff in the monitor that even if you didn't know if you didn't even know that it existed, you'd still be able to repair monitors because it just doesn't ever fail. So, we'll talk about all that as we go through this. Let's start off by taking a look at the picture tube itself. Oops, I don't want to make that brown. Something like a picture tube. Down here in the neck of the picture tube, there's something that's drawn on the schematic diagram like this. Like 3 backward L-shaped kind of things like that. And this is something which we refer to as the electron gun. It's called the electron gun. Here's an electron gun right here. Anyway, this is the electron gun. Now, as the name implies, the electron gun shoots out electrons, and they come out here. Well, if you think about it, it's a gun. A gun's got a barrel in it, and there's a hole in the end of the barrel to let the bullet out, and so there are the holes. This is actually technically known as an electron gun assembly. Inside this electron gun, there are actually 3 electron guns in there, and so that's why you see the 3 holes there. It's the electron gun. Now, in fact, this is really known as the electron gun assembly because of those 3 electron guns that are in there. Now, I have to take just a moment to remind you what an electron is. I know that we've all been through junior high school or wherever it is that you learn about atomic theory. But I just want to remind you just a little bit about what an electron is because we're going to be dealing with electrons as we go through this discussion of monitors. If you remember from junior high school or whenever it is that we learn this stuff, we know that the smallest bit of any element is known as an atom. And if you remember how an atom is built, in the center of the atom, there's something known as the nucleus of the atom. Doesn't like that, does it? In the center of the atom, there's something known as the nucleus of the atom. Nucleus, the nucleus of the atom. And then in orbit around the nucleus, there's 1 or more little subatomic particles referred to as electrons. Well, the electron is kind of like a little planet that's orbiting around the sun. Well, you know that how, like in the solar system, how we have the sun that's in the center of the solar system and all the planets orbit around the sun. Well, in a way, it's kind of the same, and in a way, it's kind of different. In the solar system, all the planets orbit in what's known as a planar orbit. They're all orbiting in what's known as the plane of the ecliptic, kind of like the rings of Saturn are all in one ring plane like this. If we could somehow look at this electron orbit, it looks different. It's all frenzied. It kind of goes all around like this, kind of like imagine a ball of yarn and seeing the final trajectory of the string as it winds around the ball. That's what that orbit would look like. And in fact, if you could see it, which you cannot, it would look like a thin shell, kind of like a thin candy shell on the outside of the nucleus. And in fact, that's what they refer refer to this as the electron shell. They call this the electron shell. Well, the point that I'm making here is this, that we know that in the solar system we have this thing called gravity, and it's gravity that keeps the planets in orbit around the sun. In the solar system, in the atom, we have a similar kind of a force that keeps the electron in orbit around the nucleus. But we don't call it gravity. It's something else. It's something that we refer to as an electrostatic force. Just relax. You don't really have to know this. I'll get to the point in just a second. It's called an electrostatic force. It's some kind of a weird force. It's kind of like gravity. It isn't gravity. It's a lot stronger than gravity. Look, I'm barely a high school graduate. I'm not a physicist, so I don't know a lot about it. I don't care. It doesn't help me fix anything to know it. But it's this electrostatic force that keeps the electron in orbit around the nucleus and kind of keeps it from flying off into space. Now, the way this works is that the electron and the nucleus have two different polarities, two different charges, as we call them. Here in the center, the nucleus has what we refer to as a positive charge. And the electron in orbit around it has the opposite charge. It has a negative charge, and opposite charges attract is really the point that I'm getting to here. You know how, like, if you put two poles of a magnet together, if you put, like, the north pole of a magnet next to the south pole of a magnet, how they attract each other? Same exact thing. Opposite poles of a magnet, north and south pole, attract. Same thing here. Opposite charges attract, and that attraction is what keeps the electron in orbit around this centrally located nucleus. Everybody with me so far? Well, the point that I'm making here is this. Two things. Number one, opposite charges attract each other. And the other half of that, and you can kind of guess where I'm going with this, is that if I try to put two of the same pole together, they'll repel each other, won't they? If I try to put two south poles or two north poles together of a magnet, those guys will repel each other. Same thing with electric charges. If I put a positive charge near a negative charge, those things will attract each other. If I try to put two negatively charged, let's say two negatively charged electrons near each other, those guys will repel away from each other. Is everybody good on that? That's kind of a pretty basic understanding. So, number one, opposite charges attract, like charges repel. Number two, and this is probably the most important thing, and this is really, really kind of where I'm going with this, an electron is a real thing. It's a real physical particle. My point is, it's not an imaginary thing. I think of an electron as like a BB, like a little sphere or a little BB, a little ball with a negative charge. Now, it may or may not be that. There's some superstring theories that say that, an electron is a vibrating string or something like that. We're just technicians. We don't care about that. But it is important to realize that it is a real thing. It has mass. It is a certain size. It has a certain weight. It occupies space. It's a real, honest-to-goodness thing. And, of course, that's what's actually shooting out of the electron gun itself. That's what's coming out of the holes in the electron gun is these electrons. Everybody cool on that? Okay. Everybody can shut off their cell phones now, okay? Including me, I suppose. I probably better do that. Hang on a sec. Let's do that. Let's all shut off our cell phones, shall we? Okay. Now, coating the inside of the glass front of the picture tube there's a substance known as phosphor, P-H-O-S-P-H-O-R. Not phosphorus. Phosphorus is what they make match heads out of and stuff like that, but something known as phosphors. And there are actually three different colors of, go back over there. There are actually three different colors of phosphor, and they're laid down in stripes or dots down in front of the screen. In some cases, they're dots. In some cases, they're stripes. I'll show them to you in just a second. There's a stripe of red phosphor. Right next to that, there's a stripe of green phosphor. And right next to that, there's a stripe of blue phosphor. And then this is repeated across the face of the picture tube, red, green, and blue. And of course, they're much more closely spaced than I'm drawing them here on the board. Red, green, and blue are the three primary colors of light. By combining red, green, and blue, we can make any color that we want. For example, if we were to mix red and blue together make a color known as magenta. I'll show you these in just a second. Blue and green mixed together make a kind of a light blue-green color known as cyan. And believe it or not, red and green mixed together make yellow. And that's what you see here on the front of the screen. Now, you'll notice that there's the display that you see on the video is a little bit different than what you're really seeing here in the class. And that's because of the difference in the scanning rate between what the camera is doing and what the monitor is doing. But what you're seeing here is this.